Okay, the next video is on the abstraction of metals. Okay, in the abstraction of metals, you need to know which metal is reactive and how does the reactivity comes to play in stability of the compound. So this is what we do. First thing you need to learn reactivity series. Potassium is the most reactive. Platinum right at the bottom is the least reactive. Now, reactive metals, they tend to form strong bonds with the non-metals, and because they form strong bonds with non-metals, they form very stable ionic compounds. So the compound is very stable. Okay, to remove the metals means to abstract the metals from the compound. Okay, and because the bonds are strong, we need to use very extreme methods. We have to use electricity. Okay, and this process is known as electrolysis. A lot of energy is being needed to just break the bonds and just abstract the iron out, the metal out. Okay. Second group here, second category, they're the more moderate metals. Okay. Form compounds where metals can be abstracted by using hydrogen, steam, carbon monoxide, or even carbon. So we just use certain simple things like gases and we can abstract metal out. And the last group, which are unreactive, which is the extreme, they basically form weaker bonds, form less stable compounds, and because the compounds are less stable, the metals can be abstracted just by heating itself. You don't really need electricity, just use heat, it will come out. That's why gold mining, gold which is somewhere in this category, can be found pure, because they simply don't react. Okay? And this is the reasons why it is also easier, comes the different ages, the copper ages, the iron ages, because technology didn't allow us to abstract aluminium until maybe recently. Maybe the last 200 years or so, but iron was found first, copper was discovered earlier, and together with gold and silver. Now, what is the meaning of abstraction? Now, metals are not found pure. They always combine with elements, different elements in the soil, from the ground, and they form a metal oxide. It's very simple, so just pretend this is just oxide layer. So I want to abstract the metal from the oxide. I just want the blue portion. If they belong to the first category, which are the reactive metal, I need to use electricity. I will go through electrolysis. Okay, and the metal oxide, from there I will get the metal and oxygen is just removed. If it is a less reactive metal, I can use hydrogen. Hydrogen will take away the oxygen and I will get steam. Or in case of the blast furnace, I will use carbon monoxide with the metal ore, and metal will be abstracted and carbon dioxide will be released. So these are different methods. And the last category is the unreactive method. You simply just heat them and they will decompose, and this is the pure metal can be obtained. So three categories: electricity, hydrogen, carbon monoxide, or even carbon, or simply just thermal decomposition, just heating. Okay, so case study of one of the methods is how can we get iron from hematite, which is an oxide. Hematite is the iron ore that we found on the ground. It's a common iron ore. So this is what is basically used. We use the raw materials, everything goes in, it's dropped into the center, and the furnace is very hot. This is the blast furnace. Air is coming in. So what happens is you get coke, which is carbon, combining with air, oxygen from the hot air, and then you get the first step, CO2. CO2 then combines with more carbon to get a gas known as CO. Now, CO is a very good gas. It is a reducing gas. This gas is used for this method. We need this gas to get the metal out from the oxide layer. So in this case, the metal oxide is iron 3 oxide, which is hematite. So look carefully. CO takes away the oxygen here. They form CO2, and the iron is free, it becomes a free metal. Okay? And CO2 is a waste gas. Usually in blast furnace, you have a pipe and the waste gas comes out. And this waste gas is CO2. Or CO can go back and can be channeled back, can combine with some more coke to get some more CO. Okay? Now, problem with this method is we have impurities, and the main impurities that is found in hematite is SiO2, okay, or silicon 4 oxide or silicon dioxide. This is the main impurity, and this must be removed. Now, impurities will be floating on the iron, and we don't want it to be there. So what do? Is we use the next raw material, which is limestone, CaCO3. We heat limestone, and limestone will decompose to form CaO plus CO2. CO2 is a waste gas, it goes. Now what we want is CaO, lime. Now lime will combine with the silicon oxide, and what it forms is something known as slag. Now slag is, or calcium silicate. Now slag is it's the compound form from these two, the main impurities and lime. So slag has a lower density than iron. Slag floats on top, forms a layer, and this can be tapped off. Iron is right there. Molten iron, which is this, there, it can be tapped off. So from there we can get pure iron from hematite, Fe2O3, using what we understood about the reactivity. So we use carbon monoxide, which is a reducing gas, to reduce this to Fe2O3 to Fe.